So welcome back from the break, and we will continue with our talks for today. It's September 2024, and we are having the fourth 2020 Zoom meeting. And our next speaker will be Pablo Reda. He will talk about raycasting. So Pablo, please go ahead.
Hi. Well, I talk about implementation of raycasting technique in R3.4. Raycasting is a technique for rendering 3D walls from a 2D maps. A famous game, Wolfenstein 3D, is one of the first. And a very good reference is the page of load graphics explaining this about this technique with source code in C. First, I translate this code to Ford and continue developing. The basic algorithm is from the point of view, traverse the map until they touch a wall, no empty cell. The map is a matrix of number with 0 is a no wall, and number the number of texture of the wall. The distance of the cell to the viewer is the height of the wall, and the position of contact of this cell is the row of the texture, and you need adjust this vector, fitting this vector to walls for avoid curve walls. I show you the texture used. For example, this is the classic game. This is the texture of the walls. And when you draw the map, you need or you like to add a sprite for things moving in the labyrinth, and for this, because it's not a real 3D, you need something like this. Is a 8 or 4 direction sprite for draw this graphic in every direction, because it's not 3D. The original source this technique make or draw the sprite vertical line by vertical line using like a zeta buffer the width of the screen, and draw the sprite for avoid the incorrect view of the sprite in the labyrinth. When I translate and I use HDL library, I not work pixel by pixel because the library have a word for call for draw the entire vertical line in the screen. This is the source code, 7 KB. Here is the initialization of the window. I load the texture and the 8 position of the sprite this is the resolution of every sprite, and this work load and cut the sprite for drawing individually. This is an dynamic array for put sprites. Well, this is the horizon. This is position and rotation of the view, and for person in the labyrinth. This is the X and Y coordinate, and this is the angle of view of every sprite, and here call the game loop. The game loop clear the screen, draw the screen. Pantalla is the Spanish word for screen, and redraw the screen, consult for a key, and every key make store in some variables the movement for for make this here this movement. These three words are the calculation for modify the position and the angle of vision, and some variables, auxiliary variables, and the big word is the draw of the screen. I go to I like to show this is the map. It's a array of byte when the number of wall or 0 with space. For clarify this, I can define the axis from X and Y to the address of this map, multiply by 24 and add. This shift are for I using a fixed point, and it's like convert to integer, this shift, and add this warm up, and then I can get the tile of the matrix. Well, I continue lower. Well, these two words add a sprite to the list of sprite. This add a person, and this make show the person in the map. Because this show is indirect, I get the angle, the X, the Y, and call to add to a list of sprite to drawing for later draw all the I need. This is the main word. Write the screen. For write the screen, traverse from 0 to screen width, and draw every horizontal line. In this case, I not draw the horizontal line, but I fill a array with the correct line in this horizontal line, because I need draw correctly, and then I sort this line for draw from far to near. I do the same with the sprite. I traverse the sprite and sort from far to near, and first I draw the floor with a gradient of color, and this is the word for correctly draw these things. Draw mix, traverse the list of sprites, and take the faster sprite, draw the line of map to this sprite, draw the sprite, and iterate to all the list. I need doing this because need the correct order of drawing. And for last, draw the rest of line of the map. They are work for trade the color, for dark the faster sprite or wall. This is the draw sprite with really put the sprite in the list because my system is 64-byte. I use much pack number for is more comfortable to me. And when in 64 number, I pack, for example, the angle, the 8, and the position in X is room for all this value. This is the struct for sprite, not so important. Where for every sprite I store X, Y, angle, zoom, where is the image, and so on. This is draw the line of the vertical line of the map, and this is the function of the SDL library, and this library is take from the array of horizontal line. The array of horizontal line is this, and when I calculate the height of the wall, this is the calculation, yes, and this is the differential, what is called, digital differential analyzer. This is the algorithm user. This is DDA. DDA is the traverse of the map until hit a wall. This is the algorithm. This is the step of the traverse algorithm. Is like this. Is this movement until they hit a wall. And this is no draw. Is stored in line, in array line, and then processed to draw in the screen. This is auxiliary word for calculate the some variables. The num of the variables are the same of this web page. And this is all. Global variables, player, and map, and this is all. Then I show this is for sprites. The problem with the sprite is working with the hide the correct portion of the sprite. And the eight angles of view of the sprite, and the darker when you are far. I can, for example, rotate all the sprites in the world for drawing the sprite. I can add a velocity to angle, or rotate it. I can move here and a ghost traversing walls, not make the checking hit. And I can do something that not is possible with the original sprite drawing is, for example, rotate. Here's the word for drawing sprite with zoom. I add zoom and rotated, and add the word for rotate for rotate. I use millisecond and scale. Oh, I need save, and now are spinning and correct drawing. Of course, sprite are 2D and is not view nice, but for make a more nice graphic of sprites, I need another technique, but it's for another chat. Well, read the code and end. Thank you, group.
Wow.
Any question?
Thank you very much. Yes, the chat says fun with force. Yeah. Are there any questions to Pablo?
So Pablo, I think in your code you print the walls and the sprites. It's Painter's algorithm, is it? You print from the furthest and then closer, and then you print walls and the sprites in order.
Yes. I need a sprite in order for occlude the wall when the sprite is in the middle of the library.
So there's no Z map. You're just printing in order from the back to the front.
Yes. With the original technique, you not need a zeta buffer. Sorry, you not need this order.
Yes.
You only with zeta buffer you resolve this situation. But I try this technique from the sort this thing and write in order.
I understand. Is that in your GitHub repo?
Again?
Is it in GitHub?
Yes. All is in Git and download and play with it.
Good.
Wonderful. Additional questions to Pablo? Okay, then thank you very much. I think everyone's encouraged to play around with that. Really, really nice. And the next speaker is Rob, and he will talk about Brett. What's it is? Brett Victor's work and force crossover. Let's have a look.
Yeah. So let me
Rob,
see.
Yeah.
Do I see if I can share Keynote?
Yeah.
So let me just check. I should be able to share. Can you still see the presentation?
Yeah, we see
good.
our slides.
So I guess this is what caused me to think this was a good idea to present. So two things, I think. One is that somebody sent me the dynamic land, and I thought, so I'll come to that in a minute. This is Brett Victor's work that he's been working on it for a few years now. I'll explain who Brett Victor is for those who don't know. Also, we get questions, and for instance, Jimmy on the mailing list maybe a few days ago asked what's your favorite 3 things of Forth, and often I find myself trying to explain what is good about Forth. Right, it's a popular topic for us guys, I guess, because people, you've got this very esoteric language, sometimes seen, well, it's an old language, and but the sort of good bits about it, it's tricky to explain the whole the reason why it's good, and although there are pieces in other programming languages and other environments, it doesn't quite work as well as it does in Forth. So what I want to do here is sort of draw some parallels between Brett Victor's work and Forth, and also there's a whole philosophy behind Forth, that even where Forth doesn't exist, that philosophy is still important. So I'll try not to take forever, because as everybody know, I can talk forever, right? So so let me get on with it. So Brett Victor, he is a guy who's worked at Apple. He's a user interface designer, but he's also a programmer, a computer scientist, and he's also got qualifications in electronics. So I put a couple of links so you can look him up. He's also got his CVs. He's put some key things there. He's quite an interesting guy. He got famous for a presentation, which yeah. So this is off his CV with a various pieces of research. He got famous for a video called "Inventing on Principle." I think that was the thing that really and so I'm going to explain there's a certain amount of irony with me talking about a dynamic environment with a slide deck, but I think I can do it anyway. So there's a couple of slides on inventing in principle. So he demonstrated a bunch of places where just writing code doesn't give you a good enough way of exploring what's actually happening. So some problems are problems that we know what the problem is, and we know what the solution is. And in those domains, there are some advantages to perhaps using more static techniques and static analysis and, things like Rust with very, very tight controls. But in reality, a lot of problems, we don't really know what the problem is, even for things we've solved before, because often what we're doing is new, and we don't really know what the solution is. And I mean, I think Chuck Moore sort of operated this way. He discovered what the problem was with building a prototype, and then built the actual solution. So this particular example from Brett, he basically he's got some code, and he wants to. It's a tree tree drawing algorithm, and he basically can click on the variables in the text window and just scrub up and down with them to alter various parameters. And this isn't the first. I mean, this created a bunch of other examples. Like there's a guy that writes a lower IDE called Zero Brain Studio. He implemented this live coding technique, and people have taken a look at this. From a Forth perspective, I quite like tweaking variables on the fly and getting immediate results. He also talked. There was also a bunch of other things in this video. It's worth watching. For instance, on the bottom right, there is a sort of a spice image, but you can see the waveforms at the various nodes. And he even had an example with the voltage and the resistor waveforms live. It got a piece of top right is a piece of code where you can see the values of variables, and this sort of visualization thing I see happening. Forth, Peter Chikaki asked, how do you visualize memory? And I find myself writing words, or even if I'm writing in C, writing in functions that I run from like a Forth interpreter to see how data structures are formed, right? On the top left, it was a sort of video game example where he was trying to figure out how high and how long the jump should be to make it feel correct. This sort of dynamic operation. So it's worth watching, because I think although he uses a lot of visual metaphors, this whole visualizing and interactivity is something which I see a lot in the Forth community as well. So this is my sort of summary. Interactive in terms of, you don't disconnect from the underlying machine and do a 20-minute recompile in order to tweak something. So we've got things like deferring forth, which I see a lot of people asking about. I also, in some of my thoughts, I got patch. Somebody was talking about, maybe it was maybe it was Peter actually talking about having a large amount of RAM and having your whole fourth running in RAM because there's a load of tricks you can run. Totally agree. I've often had patch instructions, even for subroutine threaded forth, where I can re-vector a whole bunch of interaction. I mean, these things do exist in static domains. So I always remember Marcus Pearson Notch on Java pausing Minecraft and patching the behavior of skeletons in that game as on an early video. But it's quite crude. The same is true of Visual Studio patch and continue, right? It's very fragile. There was only limited things you could tweak. You hadn't really got this sort of underlying environment. And even in Python, I don't see the Python people using that. There's some things like PyDev that can reload files. It's again restricted, but I don't actually see Python developers altering live programs in a way that perhaps we do in Forth. Interactivity, this whole fast cycle time, stepwise refinement, editing things on the fly, incremental testing, and the whole. I mean, we're seeing a few examples even today of people adapting the environment to small and large targets. That sort of flexibility. These are the sort of parallels I see. So it's also, how do we make these things more accessible, and how do we visualize this stuff? And I'll come back to that maybe in a minute. The other video that's worth watching from Brett is this future programming. He pretends to be I can't remember, 1960s or 1970s computer scientist, and actually talks about things that some of them we don't even do today that are good ideas. It sort of, he uses overhead slides. It's a whole thing to do with it, and it sort of really questions that, are we really programming in the right way? Are we heading the right direction? So that's quite an interesting video as well. The thing I wanted to get on was this dynamic land. So he's got they've effectively almost eradicated the computers in a way, or pushed them into an environment, right? So I guess in our normal lives, we've got things like Alexa that you can ask questions of, but it's not really computing in the way that we do it, I guess. This dynamic land is having on table surfaces an interactive environment, right? So the snippets of code, you see that thing in the folder on the top left, it's got snippets of code, and the older version of dynamic land uses these color markers you can see on the right picture to recognize pieces. And you can put the pieces down and it simulates that live on the table or on the floor, on the wall. This is you doing a wind simulation. And then on the bottom right, you can see a card that he's put down that causes the computer to project this. Now, there are these sort of projection systems, but this isn't it, right? This, which I'll come to in a minute. So he's got cards that maybe can play videos, but the video actually was of it interacting with real world objects, right? So as well as having markers for recognizing things, it will recognize objects and projects things onto them. So this is a way of people interacting with a computing environment live in the world, right? And there's a whole bunch of examples that people have generated. Music with different music cards and sort of wind tunnel simulations. And this is a community computing environment, that right? So it projects stuff on walls, on floors, this sort of stuff. The interesting thing is all these are small snippets of code, right? The whole sort of word philosophy in Forth springs to mind with this, small, powerful pieces that you can build up and put together. And people are solving whole bunches of problems with this sort of stuff collaboratively in a sort of open environment. But the sort of interesting thing is a couple of things. One is that these programs, they're aimed not just at computer scientists to write them, they're aimed at normal people to write them. You can also edit them live. So on the bottom right, used a keyboard to edit a piece of code inside the computer. So they're not using laptops or PCs to edit the code. They're editing it as they work on the problem, right? It doesn't need to be pieces of code. They've got demonstrations with icons, running effectively a program that you can hand draw icons and it follows a particular sequence. So you can build up any sort of interpreter to run code in the environment, if you like. And then one of the things he points out is these pieces of code are quite small because the world is really the simulation environment. It's not, if you do something inside a computer, you have to build up the complete world. They find that these things are quite small because they're dealing with these sort of environments. And people are putting these pieces of code together, and you can take pieces of code and combine them in unexpected ways. And they've got whole bunches of stuff, interactive stuff. It's not just, although the current implementation uses projectors and cameras, and I'll show you the picture what they look like in a minute. It's really sort of interacting with the world that's important here. They've got a whole bunch of stuff. The one interesting thing is the operating system for this isn't written in a piece of code in a laptop somewhere or computer. The operating system is written in, it's called RealTalk, and it's written in RealTalk. So they've got a bunch of rules, and the OS itself for the whole system is on pieces of paper on the wall, right? Small snippets of code that come together. And they work on it in the real environment. And they've got a whole bunch of different rules that anybody can look at. And their idea is to sort of push this into the community and get community, it might be scientists or they've had school children work on, be able to understand the environment. This isn't a product. This isn't something you can download. They want to be careful of. They want to build up a community of computing in the same way that mathematics and language, to a large extent, at least the lower layers, are owned by people. You can teach anybody how to, add up numbers. You don't need to go through somebody with a PhD in mathematics. So this is sort of ownership of these computing. And so they've got all these, they've got this sort of stuff where they're sort of interacting with the machine live. And they've got this thing at the bottom is a visualization of a data structure, right? So they've written a lot of visualizers, so that they're loading some sort of data out of computing unit somewhere, and they can see it and edit that data live. These things showing, so this keyboard has got to line up to that piece of code. So they're editing that piece of code in order to alter the behavioral system in the environment. I don't remember what I was going to say about this slide. And they built up this, it's not just this group that's building sort of these programs. They've had a bunch of people come into these spaces and build things on a whole bunch of topics, from weaving to molecular cloning to thermodynamics to rhythm to color to painting. They've got a whole bunch of examples on the video. And these, I won't read through this. The bottom, they went for non-profit status. So this PDF at the bottom is very interesting, right? So this is sort of local community built up, learned and taught, not downloaded. These, I knew people would be sort of interested in the what technology they're using behind. So they've got these sort of lamp stands, which have got lights in them as well, but they've got cameras and projectors. Brett himself points out that it's not, you can use, there's other things inputs into the real world. You can use anything. But they use a lot of these. They actually build them into lampstands so they could take them out to shows and exhibitions. And get people working on them in those sort of spaces. Some of these lampstands have got a computing unit in the bottom. They're not only specific about what it is. Some of them are just tethered to sort of a central one. So they can use several computers, and some of them will be sort of dumb that will be tethered to another lampstand. So the first video is only 6 minutes long. It's worth watching. And then there is the 2020 progress report has actually got a whole bunch of interesting stuff about visualization. I've got a few examples here. So they've got a visualizer that shows them heap and stack memory, right? So this is sort of interesting from a, if you ever try to debug a memory leak, they're tricky, right? Generally, Forth systems aren't big enough, but as soon as they start to become big, because you're doing a whole bunch of stuff, maybe like IP or file system work, you can end up with complex problems. The one on the, is another picture of that file system. The one on the bottom right is this is how it links together different. So if you put different pieces of paper together, how it actually links, the system links together internally via these intermediate tables, and they've got a visualizer for that as well. So they can explain how to people who aren't necessarily computer scientists, how when you put one piece of paper down, it finds what it should do with another piece of paper or another code fragment. So this is my sort of examples of why I think it's similar to Forth in a bunch of ways. There's a whole, although there's a whole bunch of parallels here, but again, it summarizes down to sort of interactivity and the ability to extend it, and not be hidden behind, somebody says the code base for Windows is like a gigabyte or several gigabytes of source code, right, in Windows, right? Well, how is that editable by anybody, right? Even Linux, that where you can download the source code, it takes you hours to build, and I don't know, months maybe to make a change in Linux, right? It's not an environment that is really commoditized to everybody. So these are sort of the things that, although they're very different projects, there's a bunch of goals that are sort of aligned in that way, which is why I thought it was interesting. I'd say watch the videos, right? I mean, the videos probably do a much better job of explaining than I do. There is a bonus video. This isn't by Brett Victor, which actually mentions Forth in this video. He talks about static languages and C++ and Rust and long compile times versus sort of dynamic and visualization. He starts off talking about punch cards and Fortran. So for a lot of us who have actually seen punch cards in operation or fail miserably with punch cards, it starts off interesting. It's a very funny video, but he mentions that some systems have a high cost of failure. This was the one slide that sort of struck a, and people think that static typing and long compile times and verifiers are the way of doing that, but obviously NASA has sent stuff up in Lisp and Forth and patched bugs while off world. So that's sort of an interesting video as well. So it's basically to try to get you to watch a couple of videos. That was my entire objective. But I think it's interesting seeing these sort of alternative systems of computing and people's alternative views, because a lot of them try to solve the same sort of problems as I think we are already solving in Forth.
Mm-hmm. Right. Thank you very much. Very inspiring. And are there any questions to Rob? Comments?
Yeah, you're going to leave any links for all those things, the
I'll
PDFs and videos?
I'll upload the PDF with all the links to the Forth 2020 group straight after this.
Great, thanks.
Mm-hmm.
No, that was really interesting, Rob. I've called them up while you're talking about them, so I've got them all open here, and I'm going to have a real good look at. Real food for thought, that one.
Yeah. Mm-hmm.
What have you done anything with it at all yourself, or?
Yeah, I mean, he's got some of the old stuff. He's got some of the old stuff on his website, but the dynamic land itself isn't there. But I think it's just I played with for his first stuff the live coding stuff. I played with there's a guy that writes Zero Brain Studio that it actually added some features for us, but which is a Lua IDE. He's got live coding there. Play with that. I think it's tricky in a lot of languages. I tried it in Lua to get it to reload pieces, and it's just it's much harder than it is in fourth, right? I could patch a word in fourth or defer a word in fourth, and even in a running system with other threads, I can get the live system to change. And a lot of languages really fight against this, right? I mean, certainly you can't do it with static language, but even the dynamic language like Python and Lua and the like, it's really hard to get that sort of dynamic interactivity where you can change bits of code on the fly. And I like the whole dynamic land where you're just playing with bits of code. And you can flip a piece of code over so it can't see it anymore, and it stops running that process, or it stops running that fragment of code. And it's just this tangibility, this touchability of code, right? This is sort of the sort of really interesting piece for me, and this is what attracts me to fourth. You see, because you can touch the code there and then and modify it, and it's the whole system's live.
Yeah. One remark: it doesn't help if the PDF is uploaded to for 2020 because 99% of the forters or inhabitants cannot access that.
Well,
So
I'll paste the links as well as a separate item.
Yeah, that's a good idea.
Yeah, we had the AM radio already in the previous talk, so making the use of more senses to get insight. And I remember that in the old DOS days there was a program called X-Ray that was capable to real-time display part of memory. And using this for force programming was also interesting because you could just display the portion of the stack and the return stack, and you could see the program actually running in real time and seeing how it manipulated the stacks. Very much similar to the LEDs and toggles that we saw earlier.
Yeah.
So it's this hands-on and this extension to additional senses. I think that is quite appealing.
Some old machines could run programs right in video RAM, so you saw literally the characters or the bits, if you had a bitmap video, flip over as your program ran.
Somebody famous said that show me your code, I won't know how it works. Show me your data, and I'll know how it works. I can't remember. I'm paraphrasing it badly, but being able to visualize and see the way data flows through a system live is nothing better.
Yeah, quite nice. Are there any additional questions? So thank you very much for all the hints, and we're looking forward. I saw parts of the videos, but not all of them, so I appreciate to have the links and enjoy them. And so you have to help me out again. I think with respect to the schedule, Bill Rexday will be the next speaker, so we decided to flip the last two talks, which in which Bill will tell us about finite state machines and force. And I know this is an ongoing topic, and we will certainly want to know what you are actually doing with state machines. Bill, please go ahead.
Very good, thank you. Delighted to be here again. By way of introduction, I'm Bill Ragsdale, the founding president of the Fourth Interest Group back in the late 70s, and helped along the way quite a bit. And I'm proud to still be active in Fourth, probably the last oldest survivor other than Chuck Moore that's still active in the Fourth community. So I will get to speak and bring this up. Let's see. I'm working on it. I had trouble getting this to go full screen. There we go. Okay. By way of early introduction, this started out as a discussion on processing CSV files, separating value files. And I had never done formal machine work before. And once I got in the middle of it, I was the most logical way to solve them in forth. So state machine, also known as a finite state machine in most of the literature. And it's defined as nodes, which of course are codes, each one of which has some input criteria which it uses to perform operations and then pass control to another node. So only one node is in control at a given time. It is, you might say, the opposite of a multitasking situation because you're only getting one code fragment at a time. And for our tool today, we're going to use the fourth case statement to form nodes. And in the future, I have another variety of this talk coming using different structures. So I found out on retrospect, there are a variety of statements. This one today is recurrent. That is, the nodes call each other until a concluding, input, and then the chain of recursion unwinds. And this is repeated. Another form can have a central dispatcher, meaning an executive program, and the executive program then calls each node in return in order, and each node gives a return code back to the dispatcher telling which code is to execute next. A version, you might say, of a go-to, where each node, a new destination dispatcher, sets up that new destination. That's a form that needs a go-to statement. Now, some examples would be everyday life, things like vending machine, traffic lights at an intersection where you have different things, different conditions. Heating system, where the thermostat has a number of settings, plus the heat system can be heating and cooling, and it can have a fan and door. Automated system, of course, would be a huge example. Burglar alarm system, when you go into an area or you're detected, reports are made, there's a way to activate and deactivate the alarm system, and it has a number of states that it is in, either idle, being disarmed, being armed, or intrusion, and so on. And finally, of course, an elevator, you have multiple call buttons, and then you have such things as the fire department override situation and an all call and so on. So here's an example of a node that I used here as a case statement. You'll see the following code examples are all built around this prototype. First, we set up some conditions for the node to operate upon. Select an input, and then the case statement tests to see which action is appropriate. So in this case, we have an action in brackets, which means it's optional, and the next node to be chosen, and it is optional what node is called. And there'll be several of those, and then finally at the bottom, you might have a default case. So CSV file, comma, separated values. The goal here is to separate those into data elements. Usually a CSV is a portable form of a spreadsheet where each of the cells is translated into a value. They're separated by commas. The essence of it is that the commas separate each of the values, but you have a problem about what happens when you have commas inside the values. So there are some reserved characters that help in that control function. On the comma, the double quote, the carriage return and line feed. So in essence, the comma separates each data element. And if you have a reserved character inside the string, then double quotes surround it. So when a item begins, if there's a double quote, it now becomes a literal string. It's used as is until a closing double quote. And what do we do about a double quote inside a string, and inside a literal string? Because it's used as a beginning and ending delimiter. So in this case, two double quotes is replaced by a single quote. And finally, the end of the line is demarked by the ASCII character turn and line feed, as typical for text files. So here's an example of the first case. Here we have a comma that's embedded, XXX comma XXX. So to delimit that, there's a beginning and ending double quote. Here's an example of a double quote within a item. So in this case, it's shown as a literal string by having a double quote at the beginning and the end, and in the middle, the double quote is replaced by a single double quote. And finally, here's one that's more complicated. In this case, the literal string actually has double quotes inside the literal string and a comma and a blank. So you see how the code has to strip away those outer double quotes and pass all the interior text to the output. There's a simple line of text that I use for my test data. We'll see this process later on, but there's a mixture then of pure text, of items that have quotes, embedded quotes, leading and trailing, so on. So here is the logic that I applied in solving the problem. At the beginning, I just thought I could write some indented if then else's, begin again, set up a couple of loops, call a couple of words, and I found out that the process is more intricate than that structure allows, and the logic form really got pretty complicated very quickly. Another approach I thought was a table-driven state machine. In this case, we have a table, most likely written in binary, and that table contains a node identifier for each of the states. It contains a node identifier, the inputs to be selected, the actions to be selected, and the next node, so that the operation is just moving from row to row in the table. Each row specifies the operations, and the output specifies the next node. This is nice in that it is very maintainable and very general, but it got pretty complicated. I began to have to parse the table, pull out all the actions, and work from that. Another approach is using a direct transfer between the nodes using a go-to statement. And we'll probably, if things work out right, next month, I'll do a presentation on that method. So what I came up with was state machine, logic-driven, and recursive. So it's a combination of recursion and the case statement. The state nodes we'll see, the very first node detects and processes the very first character. Another node processes subsequent characters if they're in a non-literal field, or processes the next character if it is in a literal field. Another process is found in a literal field. And here is a line diagram, a flow diagram of the state machine. On the left, we see the driving program. This just sets up the data and passes it to the series of nodes. The first character is processed by the node that says first character, and there are two decisions. If there's a double quote encountered, then it takes the upper path to a literal field. If the first character is not a quote, it goes to the lower area to a non-literal field. In the non-literal field, then all the characters are taken in line, and the fourth word in this case calls itself over and over and over again until it meets a terminal condition. In the double quote case, taking the upper path, this goes to the node literal field. In this case, it has two choices. If in the literal field it encounters a double quote, it's handled by the node quote in literal, returns in a loop. If, on the other hand, the literal field does not find a quote, it again is processing character by character and recursing. In all cases, to the right, we see the terminating characteristic. If a comma is encountered or the hexadecimal OD, which is carried return. In this case, the recursive field unnest, getting back to the driver, and the driver then does a display. The driving program very simply sets up two text buffers. It sets the in-character buffer to 0 and the out-character buffer to 0, and it passes control into a looping structure. Now notice that stick bar shown twice is only used for report formatting. You'll see how later on in the reports we see the little bar isolate to highlight where our output. The node call is first character, as we saw in that flow diagram, and in this case, that's all we see here. We see the first character execute, but remember that it goes into the chain of other nodes, and they circulate node to node to node to node, still reaching a comma or a character turn. If the series ends upon a comma, the while function executes, and it just shows us what the text was that was decoded. Hit a space, we reset the out character back to 0 again, and then loop back to begin. So upon each comma, we just get the begin while, begin while, begin while. Upon reaching the character turn, the repeat function is passed over, and we print the concluding field. So that print field at the bottom executes only at the very last field in a line. So the node that processes the first character, the fetch in character and plus in character fetches that character and then increments to the next character and then passes that to the case statement. So that first character is tested against ASCII quote. If it is an ASCII quote, the of portion executes and it calls literal field. If instead it encounters an ASCII comma, it executes true. If a hex OD is encountered, it executes false. Just back to that driving control program. If none of those happens, then we are in a multi-character field, and so that it takes the character that has received, it stores it into the out character part of a data array, and then increments the out character by 1. The case statement requires a concluding parameter on here, so there's a dummy character of 666 that satisfies end case. Normally, end case would be processing that last character that was default, but we've used that to store into our information output, so we have to replace it with a dummy 666. For a non-literal field, in this case, the text is just going to be read through that particular field until a comma. So in this case, the fetch in character plus in character gets that next character in line. It tests for the ASCII comma, if so, execute true. Look for a return, if so, execute false. Otherwise, this is now just working its way. It's chewing its way through that data field character by character. So it stores this output character and then increments for the next character. And then since we are in a continuing non-literal field, it just recurses, calls itself again to process the next character. Things are handled a bit differently in a literal field. In this case, we're looking for the closing quote. So here, we fetch the input character, pass it by the case statement to an OD. Now at this point, if a return is found, it's a format error. So the program aborts, giving format error 2. If the ASCII quote is found, now we have a double quote. So remember, we got into this with a quote. We now encounter a double quote. So then we execute the node that's quote in literal. So this is taking the double quote and converting it to a single quote. And again, if none of those apply, then the character is simply put into the output, and we recurse. Call this again. And again, the dummy 888 at the end satisfies the syntax for end case. If now we are in the case of having a quote inside, a double quote inside a field. So in this case, we look for an ASCII quote. If the ASCII quote is there, the output is now converted to an ASCII quote, and that is fed to the output. So remember, we got here by having two quotes in series, and they are replaced by the single ASCII quote into the output character. And then we conclude this by continuing on literal field. Otherwise, if we encounter an ASCII comma, execute true, return execute false, again taking us back to that outer control structure. If none of this happens, we've had a format error, unexpected character, and so we get an abort with a format error of 1. Here's another review of what the state machine looks like. We've seen all the components. Remember how the driver gets it started. It passes controls on the first character. It checks for the double quote. It goes through that upper sequence of literal field and quote in literal. And the lower section is handling just plain old non-literal field character by character. And finally, at the right, we see our execute. So the code very clearly, very simply follows these simple modules. And it came out amazingly clear. It's a very good relationship between the format, the fourth case structures, and the logic of the execution. Here's an example. This is our input. This is what you would see in a dump of the text file, in a dump of the CSV file in text form. And then at the beginning, it starts out with this is, which is a plain text field. And then there's text with quotes, double quotes, a mixture and comma. And we'll see now how this is output. Now remember that stick bar command there. That simply puts these vertical bars in between the fields, so we can check as a consistency check. And sure enough, the this is translates straight across. The next sequence has some double quotes in it, and that is a file and double quotes. Then there's the with a buried quote in the middle, and then other elements. And finally, at the bottom are simple things like phone number and a date and a time. What about alternatives? Matt Hodges on GitHub put up an interesting one that I stumbled onto in researching this. And he said, since using printing characters, such as the commas and the quotes, are a little bit messy and they are subject to interpretation and there are different formats, how about using non-printing characters as separators? He proposed using the hex, I guess it's decimal 30, as a record separator, and decimal 31 as a unit, which is called unit separator, using those two to separate the end of line and the fields. So he would use 31 as the field delimiter in between each of the data items, and then put 30 at the end for a new line. But it is a little bit tempting, but because in this case it's you don't have to decode it. All you immediately have your end of elements and your end of lines, but you cannot edit this with our common control alternate control C control V, and you couldn't screen edit using a mouse and a cursor because you have these non-display characters. So these non-printing characters would be fine if you were doing data storage and data transmission, but they would not be suitable really for editing, debugging, testing, and visual use. So to conclude, there are many subtle variations of the CSV format. I looked it up on Wikipedia, and I found out there were several alternatives on it. In some cases, the double quotes to for reserved characters do not delimit at the beginning and the end of a data field, but the transition to a literal field can be done inside a field. Excel seems to be robust because it appears to accept a variety of input CSV formats. It generates always the same consistent format, which is the one we handled here today, but it does seem to be robust in handling a lot of variations. So next time we'll use a fork goto doing this. Now there is no inherent fork goto, because remember, each node in a pure network situation, each node leads to the next node with no return path. And so your nodes execute until finally you hit a terminating node, and that returns control back to the host program. So next time we'll look at how do we do this. Instead of using a case statement, we will be using a goto. Do we have any questions or comments?
I mentioned this in the chat, but this reminded me of something that someone on Reddit complained about, where a prior coworker of theirs decided to use the Unicode zero width space, non-breaking space as a separator character, and they ran into this perplexing problem of why when they copy and paste the data, it worked correctly, but when they hand wrote the data in, it didn't work. And it took them quite some time to figure out what their former coworker had done. So I personally wouldn't recommend that guys set suggestions for that reason.
No, I agree completely. I agree. Many times during this process, I would pop into I'd take my text file and I'd pop it into a word, not a binary, but a pure ASCII display. I want a pure ASCII display. I want to see all the characters. I want to see everything there. And getting involved with non-printing characters makes life quite difficult. Any other comments?
Yeah, I want to comment with an excellent, clear lecture. That's all.
Well, I would put out a commercial for the management. You love code, you love your source code, but when you put out the whole scale, very, very, very small on the screen. So really expand or pull the code out and put it into a presentation. Because I love to read your code, but with my aging eyesight, I've got 84-year-old eyes, and it didn't read with code on the screen. We're going to come and wrap up here. Thank you for the opportunity to present. It's always a pleasure to meet again with this, because you are the most active.
Yeah, thank you very much. So it's again a really great meeting today with lots of interesting impulses. I really always appreciate that. So Bill, thank you very much for sharing your ideas. And I'm looking forward to the goto solution, because recurse of course stresses the return stack, and we will see. Yeah, great. Thank you very much. And then we conclude this meeting with Brad Nelson's session on ESP32 fourth, and we're looking forward to the news that Brad can tell us.
All right. I've got only one bit of news. An interesting API that I decided to make some use of in connection with ESP32 4th. So there's this new web API that will allow me to pull the magic trick of proposing that, assuming you have the Chrome browser on your computer, you may already have a serial terminal that you can use. What this is that about 2021, a new API got introduced that allows reading and writing to serial devices, USB devices, Bluetooth serial devices, so anything that sort of behaves like a serial port. This API is unfortunately Chrome only. Other browsers like Safari have not adopted it, although I think it may be an Edge actually also. It's a Chromium derived browser. And then what it does is it provides a method for you to pair with a device and then do asynchronous I/O with that device. It's sort of typical of contemporary web APIs. It uses a concept called promises that if I can get a mind to at some point, I've often wondered what these would look like in Forth. But the idea is that you can request pairing with a device, and it returns a promise to sort of wait on the on that operation to complete. And then after that, you can check to see if there are any devices that have been granted permission to interact with your particular website. And then you can open a port and then get a reader or writer object. It's very object-oriented interfaces, and then do an asynchronous read or write using an array buffer, which is another JavaScript concept that lets you deal with raw bytes. So I wanted to add this into the web version of Micro eForth, which is the Forth that powers ESP32 Forth. And the web version has the ability to inject little chunks of JavaScript in what is called a raw string. So it starts with this little R tilde. And then what I do is keep track of the set of data that is in a buffer headed to the serial port, from the serial port. And then I keep track of the set of current ports connected, and then I pick one of them to be the active port. And then I also keep track of the current writer that can be used to send bytes. And then there's this concept of an async function that has been introduced in the last many years ago now to JavaScript, which is something where it will operate, and then whenever it gets to an operation that is asynchronous, it will sort of yield control back to the main event loop. And so you can do an await operation to open a port, and you pick the baud rate, although with the serial API, what actually happens is this is just a hint. And so if you've got a USB serial device, for example, it will typically auto select the baud rate and happily disregard you if there's something on the other side of it that wants another baud rate. And then I open up a writer so that I can later on send bytes to it. And then I create this event pump, which just gets a reader from any of the active devices, attempts to read a single byte, and then, apologies, sorry, not a single byte, a chunk of whatever length, and then it checks to see if this particular reader is done, meaning it's sort of gotten a break in the connection. And then if it is, it releases the internal lock on that reader, and then I feed all of this data into a buffer. I also have an operation to scan for updates. There are a couple of events that can cause changes in which serial ports are present. So I'll check to ask for a promise for the set of ports, and then the then operation lets you sort of continue once that promise has completed. And using that set of ports, I will update those state variables that I mentioned before, and then call this prior route serial operation to create a pump. And so the net is that this buffer will contain inbound bytes, and this writer will be available to send bytes outward, which is ultimately all I want to plummet into Forth. One more thing I do is I register some listeners to do this update serial operation whenever something changes about the connections of the serial ports. And then finally, for the web version of Micro eForth, there is the ability to define words in JavaScript. And I believe I only need 3 words, is it? I'm forgetting now. So one is pair serial, which does the operation of attempting to do a pairing operation with a device. The reason they have this pairing step is you don't want a random website that you go to be able to just decide to access your serial port. That would be dangerous. In fact, that as I understand it from knowing folks involved in web browsers, that danger, even in the case where you have agreed to it, is one of the debates in exactly how to have it look that kept this API from prime time for a long time. And then I have a word that is this probably unnecessarily verbose serial key read raw, which reads a single byte from a serial port or -1 if there is nothing available. So it's a non-blocking word. And then I have serial type, which can send a whole buffer out to the serial port, or it will happily swallow the data if that data isn't available. And if folks are ever tinkering with the web version of Micro eForth, it sort of demonstrates an interesting thing about defining words in JavaScript in combination with Forth. You can pass in locals and then reference them in the JavaScript code. And then using these, I'm able to create a Forth pump that pauses to yield anything else going on in the system, checks to see if there is a character available from the serial port. If it is, it emits it to the terminal. Otherwise, it drops the -1. And then it checks to see if there is a key from the user. And if there is, it reads that into using some excessive magic here to read that value into the return stack, which I use as a temporary buffer to then call type, and then I clear out the return stack. And so this essentially is just redirecting serial input to the Forth output device, whatever that happens to be, and the input device to the serial port. The web version of Micro eForth can be embedded in a web page just by including a single JS file, and then you can have scripting tags in Forth. So I'm able to build a very simple serial terminal. I have a yes/no word that waits for a single key, and if it's yes, it returns true and otherwise false. All of those words that I mentioned previously are inside of the web vocabulary. So I activate that vocabulary and then define a word called go that prints out, hi, I'm a serial terminal, asks if you want to pair. If you do, then it pairs. Otherwise, it goes into that infinite pump. I switch back to the Forth vocabulary just out of neatness and then go ahead and run. So now I'm going to switch over and demo it. For the purposes of the demo, I've got a device. I've got a couple of devices here, but one that I can't say I recommend particularly. It's the T-Dongle S3. It's got an ESP32 S3. Here's the actual device on a little stick. Ooh, and I dropped it. It has a little display, and 2 things about it that I don't particularly care for, but I'm using it for the demo because it's easy to carry around. One is that it gets very hot when plugged in for reasons that I can't really fathom. The other issue is that the head I've had to super glue because after being inserted and removed several times, it's fallen out. So in any event, let me, so this functionality is available, on the ESP32 website. I'll do this sort of 2 ways round. let me shrink the font. So actually that's probably reasonable. Okay. So little known thing here, when you are on a website in Chrome, there's a bunch of options under this little icon that shows you things about the site. And so the first thing I'm going to do is I'm going to insert this this device into the serial port. And then I'm going to do, I'm going to go into that web vocabulary I mentioned, and then I'll do pair serial. And it pops up this dialog, noticing that and it shows the one device that's there. If there are several devices, you could choose which one to connect to, and then you can connect to it. And then after that, if I do this serial pump, I'm now talking to the serial device. And I don't know, let's see, to demonstrate that I can do an ls on the SPI file system. If you now remove that device, it will be broken. The connection is broken, but it is fairly smart about reestablishing the connection, and you can use it. You could have several devices, although it will just favor the first that was connected. To make it easy to use the steps that I've just shown, there's a currently undocumented thing at e4appspot.com/serial that sort of offers to pair. I'm going to stick in this second device. I've got a bunch of random ESP32s on a board here. And I will go ahead and say pair, and now it's offering me two options. It knows that this one's previously paired, so I'm going to pick the second one. And then now I've got this older board that's got some earlier version of things running on it. If you wanted, if you click on the icon that I mentioned before, you can see that associated with this web origin are these two devices, and so these two have been granted permission to interact with it, and you can revoke that permission, this little X. So I'm going to remove this other guy, and I'm going to reload and show one other thing. So I'm not going to pair this time because I already had a device connected, and in ESP32 even I've got these terminal words defined, so you could interact with a color terminal. And this is a color terminal, which is nice. You can do things like, print out, and I'll go back to the normal color and the carriage return. So you could define something like that and see a bunch of colors. You remember that there's a visual editor on the ESP32 as well. I can use it to open up so it's in the visual vocabulary, and then edit expects one word after it with the path. So I'll open up this file, and this terminal can interact with this understands the appropriate escape codes to be able to print this terminal. It is not a full. It's a very narrow subset of VT100 with a couple of extensions for color, but by no means everything is in there. And that is it. Are there any questions?
My question would be, how do you set the baud rate?
So currently I am leaning heavily into the assumption that the device connected will be a USB serial device and will not care what the baud rate is, but it is a fair point that I probably should have that option exposed somewhere. Right now it is baked in that it is 115200.
I see. Yeah, thank you.
Is there a way to have a serial device interact with eForth? So in other words, you could connect to a serial device out in the field and have it send data to the eForth interface?
So in principle, so if we go back to the web one here, and maybe I'm not getting at the, make sure I've got your question right around. So the web version, after you've paired with a device, although in this example, oops, that's not what I wanted to do. In this example, I just have this this serial word, which is like a pump. If you wanted instead to actually interact with the device and send it, you could send it, particular serial operations of your own choosing. So I happen to have just set this up as a bidirectional terminal to the display, but you could just send raw serial writes or reads to it. Does that answer your question, or maybe I wasn't quite getting?
Yeah, I believe so. That would be very interesting to be able to, have a UE4th engine that interacts with serial devices out in the field somehow.
Yeah.
And then follow on would be, how would this relate to like WebAssembly, WASM, which is the assembled version?
So it's not directly related. I mean, I guess it's WebAssembly is a sort of a separate mechanism in the browser. There is a very indirect relationship in the sense that the web version of Micro E4th internally is written so that it emits an ASM.js piece of code, and it happens to be I used to work on Chrome, and it happens to be the case that internally that will get converted to a WebAssembly module, but that is just an implementation artifact. WebAssembly is the way to think of it is that it is a set of web APIs that allow you to run low-level code on the web. It doesn't provide direct low-level access to devices. So for that, you have to rely on other APIs in the web, and Web Serial is one. There's also a Web USB API that's recently come out, and so typically with WebASM, you're needing to interact with outside. There are versions of WebASM that run outside of the browser, and that's a whole another more complicated story. But
very nice, very nice.
So I encourage folks to try it out. If you've got Chrome on your device and you go to the URL I put in here, you can use it if you've got some serial device to hook it up to. You have one more serial terminal, and this will save me the trouble in the future. I often use the PuTTY. PuTTY can act as a serial terminal, and this is sort of one step easier because now it's one less thing to install.
Right. Well, thank you very much. Are there any additional questions?
Not a question, but I am impressed every time I see Brad's efforts to extend all the features we have in ESP32 Force. This is why I use it, because it's so it's so useful for me, and it's easy to program. When I see Force from other developers, I never tried Travis, but I have a lot of positive comments about Travis' work. I'm not using the Raspberry Pico because I don't have so much time for many platforms, and ESP works for me, so I keep working with that. And now is Peter Jackeke adding to the effort of Brad. You all know how prolific Peter Jackeke's work with Tachyon is, and how fast. And he has a lot of knowledge from the industry, Peter develops his boards and installs at customers. We always talk with Peter with the same, we are in the same page, we have the same view that force is the best, one of the best languages and one of the best philosophies for embedded systems and to solve problems in the real world. We work in the real world. We are not theorists. We are not making theory about languages. We solve every week problems for customers or problems for ourselves in the case of a hobby. And the work of Brad in that aspect is brilliant. I can edit, I can use the assembly, which is inside of the chip. I don't need external tools. I don't need Bluetooth, which we need in C and other languages. So I need to say it's super important and super useful.
Yeah, thank you for the comment. I appreciate that. And thanks also, Brad, for all the effort you put in that. So it's always amazing how great the system progresses.
Thank you for the kind words.
Also, I want to say something very shortly to Bill. Is Bill on the meeting now? He's gone. Both Brad and Bill Ragsdale are presenting always at the SVFIC meetings, as you probably know. And I asked them, no worries, come to our meeting and duplicate your presence on video, because probably on SVFIC you reach one kind of people, and probably also you find new people here on our Zoom. And in any case, we both sent this to YouTube channels. Both channels are very successful in the moment, SVFIC as Force 2020. So we reinforce the presence of Force on the web.
Right. So I think
Christian has a question, Ulrich.
Christian.
Yes.
The question. Go ahead.
Did someone say that I had a question?
Yes,
No,
I said.
I don't have one.
Wow, that's a surprise. That's a surprise. Yeah, anyway. So that's something to celebrate. I think this concludes our meeting for today. We keep the conference running on and let it run, but I will just stop the recording. So thanks everyone for watching this later on YouTube, for staying with us, and see you next time.
Thank you.